All right, in chapter 2, we're going to start off talking about relations and functions. So a relation is a set of pairs of input and output values. And just some vocab real quick, a domain represents all the set of inputs of a relation or all of your x values. Your range would be the set of your outputs, or in other words, your y coordinates. There's a couple different ways you could represent relations. Some are more common than others, but I thought now would be a good time to just go over different ways you might see these. Ordered pairs are common. Ordered pairs are listed as your input, output. A mapping diagram you're not going to see as much, but here you can just kind of see your inputs are listed on a column, and then they have an arrow going to their output. Next, you could see a table. Last but not least, you could just plot those points out on a graph. Going more specific, a function is a relation in which each element of the domain corresponds with exactly one element of the range. Basically, this is a fancy way of saying for every input, there's one and only one unique output. So every x value can only go to one special y value. If you have the same x value going to different y values, this is not a function. So let's go over real quick. Sometimes we'll be able to see, judging off of how these are represented to us, we can determine if a relation is a function. Remember, again, the key here is I'm looking for each x coordinate to only be going to one y coordinate. First, we have a mapping diagram. So here we have all our x values in the left column and our y values or our range in the y column. What I'm looking for here, I see -3 only goes to one number, -2. 0 only goes to 7, and 4 only goes to 1. So judging off of that, yes, I can say that this relation is a function. In this next problem, I have a list of ordered pairs. So here, again, the key is I want to see that each x coordinate corresponds with only one y value. If so, I'm good to go. Here, though, while I'm looking at this, something that sticks out to me is that I have two coordinates that start at 4, or that my input is 4, but they go to different y coordinates. So this shows me I have 4 going to -1, but 4 is also going to +1. That right there is all I need to know to tell me that no, this is not a function. Now, sometimes it's kind of hard to be able to determine whether something's a relation or a function if I'm just given a list of ordered pairs or maybe a mapping diagram. The easiest way to see if something's a function or not is by graphing out your points and using something called the vertical line test, which you might have already talked about in Algebra 1. The vertical line test basically states that if a vertical line passes through more than one point on a graph of a relation, then the relation is not a function. Okay? So here I have two pictures on the left and right of two relations. On the left, that would not be a function because if I drew a vertical line, that relation passes through more than once. On the other hand, on this graph to the right, even though this line seems kind of squiggly and going all over the place, I can draw as many vertical lines as I want, and it's only going to pass through one time. So that would be a function. So you might be wondering how exactly that works, so we'll get into a little bit more detail of why that's the case. The vertical line test works because here, let's say I have this parabola here, it's not going to pass the vertical line test, and let's see why not. I'm going to draw a vertical line in red here, and I see that on my blue relation, it passes through 2 points. Let's call that top point x, y1, and that bottom coordinate x, y2. And what you're going to see here is that this is visually representing I have the same input value or my same x value, which is why they're stacked on top of each other like that, but I have different outputs or different y values. So when you see something not passing the vertical line test, you're just seeing visually having the same input going to two different outputs. That's what that looks like. Now, the last thing that we're going to talk about today, while we're talking about inputs and outputs, I thought this would be a good time to go over function notation. This, again, is a topic that you've most likely already covered in Algebra 1 or even before that in middle school. Function notation is basically just writing an equation that represents an output value in terms of the input value. So in Algebra 1, you were used to seeing equations like this, y equals 3x plus 2. What we know here is that y always usually represents our output and x represents our input value. As we move up into harder classes such as Honors Algebra 2 or Calculus or any upper level math class, instead of writing our output as y or some different variable, we want to write it in terms of x. So, commonly, how you'd write that in function notation is saying f of x. That's the only thing that changes. An independent variable x will always represent the input of the function, while the dependent variable is going to be f of x, and that's going to represent the output. So as we move forward, you're going to see a lot of equations just written out in function notation. So just know that x represents your input, f of x is your output. And to end this video, let's just go over a couple practice problems of how to use function notation. In part A, we have the function f of x equals 17x plus 3. And here I want to solve for f of 4. So what's important to know here is that I'm not trying to isolate a variable. I already have my rule, so this is going to be pretty straightforward. To solve for f of 4, that's just telling me plug in 4 where you see an x. So f of 4 is going to equal 17 times 4 plus 3, which is 71, and I'm done. Last problem, I have f of x equals 3x squared minus 2x plus 1. And in this first part, I want to solve for f of 1. Now, sometimes in these problems, I'll get questions like, where do I plug in the x, where I see it in multiple places? What you want to know here is that for function notation, wherever I see an x, I'm going to plug in with the number they're telling me to plug in. So here, wherever I see an x, I'm going to plug in a 1. So f of 1 is going to equal 3 times 1 squared minus 2 times 1 plus 1. Plugging that all in my calculator, f of 1 is going to equal 2. Last problem, I want to solve for f of negative 2. Again, I'm going to plug in now a negative 2 wherever I see an x. So f of negative 2 equals 3 times negative 2 squared minus 2 times negative 2 plus 1. When I put that all in my calculator, know that negative 2 squared will come out to be positive 4. 3 times 4 plus 1 will give me 17, and I'm done.